Good afternoon, ladies and gentlemen. We're pleased to bring you the Women of Innovation panel, where we'll be talking about lessons, challenges, and success. In 2005, the Connecticut Technology Council inducted 50 women into our Women of Innovation program. Since then, we've named over 400 women as Women of Innovation. These are all remarkable women who work or study here in Connecticut. We believe that celebrating their successes of these outstanding women gives role models to the up-and-coming women who study and work in STEM fields. Why is this important to the individuals, the companies, and the general economy? Stats say that women are gaining ground in many disciplines, but the fact remains that the overwhelming majority of scientists and engineers in senior executive positions are white men. I know that probably doesn't come as a shock to those of you who have attended technical meetings, but it's true. The CTC wants to impact this lack of diversity in companies and institutions by sharing the message that diversity pays off. So please hear this. Diversity of personnel correlates positively to innovation, sales, number of customers, and profits relative to their competitors. Years of business school studies on performance, productivity, and profitability tell corporate leadership that companies should invest in diversity, not to be altruistic, but for their own financial success. We are thrilled to bring you here this panel discussion with 3 of our Women of Innovation who work in manufacturing environments. Bonnie Del Conte will moderate the discussion. Bonnie is president of CONNSTEP, which through federal and state funding assists small and mid-sized companies by providing services around lean manufacturing and quality improvement and much more, all designed to help companies succeed. I encourage the manufacturers here to learn more about CONNSTEP and their offerings that will help grow your business. Bonnie?
Thank you, Paige. Can you hear me? Good afternoon. Can you hear me out there? Yeah, thank you. Thank you. Good afternoon and welcome. I'm thrilled to be here and thrilled to be with 3 energetic, bright women in engineering. From my role of being president and CEO of CONNSTEP, we service the small to medium-sized manufacturer in our state, and I can say that there is a minority in my client base, when I'm working with them, of the women that are in those fields, and even more important, there's still a lack of entrants coming into this field, even in 2014. We've made some strides over those hurdles, but not as much as we can. So today I'd like you to hear from our 3 panelists a little bit about, first of all, who they are, secondly, some of their career choices and how they got there, some of the opportunities, some of the risks, and some of the good successes that I'm sure you'll hear from 3 very, very capable women. I'd like to introduce my colleagues here. Julie Renner is presently a postdoctoral fellow at Proton OnSite. We have Severine Zygmont, who is a co-founder and chief operating officer at Oxford Performance Materials. And we have Reshma Shanku, who also comes to us. I'm going to read this one because it's a piece of Sikorsky Aircraft Corporation called TUHP, which is the Turkish Utility Helicopter Program. So what I'd like to do is, again, start with Julie and give you a little bit about Julie's background and a little bit about what she's doing in her current company. Julie?
Can you hear me? Can you guys hear me? Okay. So thank you for having me on this panel. I'm originally from North Dakota. That's where I grew up. So I got my Bachelor of Science in Chemical Engineering at the University of North Dakota. And there I was lucky enough to get a fellowship through the EPA, which funded my undergraduate education as well as gave me a chance to do research at an EPA facility for a summer. And that inspired me to go to graduate school. So I attended Purdue University to get my PhD in chemical engineering. I graduated in 2012. And from there, I decided that I wanted to get some industry experience. So I wanted to land the elusive postdoctoral postdoctoral position in industry. So I obtained a fellowship through the American Society of Engineering Education to be able to do that. The fellowship allows or encourages recipients of PhD degrees to enter into a small business and work there for 2 years on hands-on research. So I decided to do my fellowship at Proton OnSite in Connecticut, and that's where I am now. So right now the fellowship has given me the opportunity to write a lot of proposals, to attend conferences, to lead projects, as well as conduct some pretty interesting research. So that's where I am right now. Proton OnSite, for those of you who don't know what they do, they're a world leader in something called proton exchange membrane electrolysis. So they make hydrogen generators. It's what you would expect it's what you would expect to find in a hydrogen fueling station if we had fuel cell cars. So I think that gives you a little bit of my background. I'll let my friend here give you her background.
Hi, so I'm Zygmont, and thank you very much, for having me today. It's really nice to be able to talk about innovation and women all at the same time. So I would say my journey started 15 years ago here when I came to the state, but really started, I would say, 25 years ago when I really realized that math and science was something I was kind of good at. So that's really led me to get into the engineering field. So but quite some time now, I graduated from in chemical engineering and industrial engineering from the French university in the north part of France. But at that time, I kind of decided that maybe going abroad as an exchange student would be a good idea. So this is where I came about 15 years ago, and actually never left. So the interest for the journey, I think, is when I decided that outside of the technical field, I really wanted to learn the business. One of the nice ways of starting with engineering or any other technical degree is we teach you a lot of lessons into how to apply problem solving, how to approach problems in general, just to approach situations. But I really had a desire to apply that into more of the business environment. So at that point, I was lucky enough to find an internship with a small company in Connecticut about 15 years ago, and I really started to get involved in all different aspects of the business over 15 years, whether it was, the technical side of it from, figuring out how we're going to, market the product, talking to the engineer, to taking over all the different responsibilities you would do in a small business, from accounting to packaging to anything you would have to do, financing and capital raising. So, the important lesson here is starting with a technical degree really opens the door for you to do a lot more than just, being a special, being just I would say, a specialist in this field is really, for me, was really an entry level in the business world as well. So, 15 years later, I'm here still with the same company that was originally founded by Scott DeFelice, who, I'm sure we're going to talk about mentorship a little further in some other discussion, but really opened the door for me in learning how to grow a company and run a company and connected. So I'm very proud to where we are today and to be part of OPM, also Performance Materials, and we are today, a leading company in additive manufacturing using high performance material. We are the first company to actually receive clearance from the FDA to make cranial implant using 3D printing. And we've also, one of the leading companies in the aerospace, world, working with Northrop on developing a database to make parts, on some of the new generation of aircraft. So I guess that's part of it.
Reshma, Shanku. Glad to be here. Thank you for inviting me to be part of this panel. I originally from India. I did my undergrad in mechanical engineering and came to the United States for graduate studies. So I got a master's and a PhD in material science and engineering from the University of Mississippi. It was a small school, it was a great place to learn. When I got out of school, I got a job with a small business. It was a woman-owned small business in Texas. I worked there for 2 years. We did SBIRs, the Small Business Innovative Research Projects. After that, in 2 years, I went to join my husband actually in Indiana since he was working at Rolls-Royce and I was in Texas. So the long distance for 2 years kind of took a toll on us. And so we were trying to get back together and start a family. So we moved to, I moved to Indiana to work for Rolls-Royce, and I was there for 12 years. Worked on jet engines and progressed through the materials organization into the project engineering role. And I was the assistant chief project engineer there when we got an opportunity to move to Sikorsky. So my husband and I both made the move actually to Sikorsky a couple of years ago. And I moved to Sikorsky as the chief engineer for the international maritime programs, where I had the technical leadership for all the design, development, aftermarket, and production support for the aircraft. A few months ago, I got a new opportunity within Sikorsky to move to the TUHP program, which is the Turkish utility helicopter program. It is a co-production program with the prime subcontractor at TAI will produce this aircraft with our assistance for use in Turkish, for Turkish users. We will also buy back the helicopter that's produced in Turkey for our other customers internationally. Sikorsky is a world leader in design, manufacture, and aftermarket services for commercial and military helicopters. We also have spare parts, maintenance, overhaul, and repair facilities that are provided to the products we produce, commercially, military products, as well as the fixed-wing aircraft that we produce. In 1923, Igor Sikorsky, who was an immigrant to the United States at the time, had just immigrated a few years ago, founded this company and named it Sikorsky Aero Engineering Company. In 1929, it became a subsidiary. There was a plant in Stratford, there was land in Stratford that was procured, and a facility was established as part of the United Aircraft Corporation that has evolved to United Technologies Corporation today. In the 1970s is when that evolution took place. We celebrated our 90th anniversary last year since it was founded in 1923. To this day, the company lives by and stays by the passion that Igor Sikorsky had for safety and innovation. The mission statement for the company is that we pioneer flight solutions that bring people home everywhere, every time.
Great, thank you so much. I want to start with asking about how you got interested in your careers, because it seems, as I mentioned earlier, that in 2014 there still isn't a steady path of attraction for women to come into the STEM fields. But really, what's even bigger than that is that there's still not a lot of information out there early on in careers. I read a study a few months back that still makes me very surprised that in some of the elementary school teachings, we are still taught as women that we're not as skillful in math and science. The boys are still a little bit have an easier time with that, and some of the softer skills are still encouraged. There's not a lot of talk about a career path in high school, and a lot of times it's not even till college, till second or third year in, that something transpires that intrigues you about some of these other fields that have a job. Usually at the end of the tunnel, these are jobs that are there when you get out of college. The pay scale is greater, sometimes anywhere from 18 to 30%, and the opportunities are there to excel. So it behooves me to understand how this is still going on, but how did it affect you and how did you get interested? And if it did, where in your career did the light sort of go off and you're interested? They've all given me in some of our conversations that they've had people, some mentors, or it's been in their family, but I'd like to hear what really was that transformation that maybe we can pass off as some words of encouragement as we promote this field. So, Julie, I'll start with you.
Okay. I think we talked a little bit about how I went to a very small school growing up, and so it never really occurred to me that I wasn't encouraged to go into math or science because it was a very small classroom atmosphere. I could take classes with the older kids or the younger kids, so if I was ahead or behind, it didn't seem to matter that much. I could catch up by taking classes with the lower ones, or I could take classes, which typically were math or science, with the older classes. So that really helped. I never had, I guess, that impression, but I also had a really unique situation growing up where I did. That said, I didn't know about engineering until I got to college, and I only really ended up being an engineer because I was really interested in everything, and somebody just told me to try engineering because they kind of do everything. And it seemed really challenging, and that kind of motivated me to do it. I wanted, and additionally, what really motivated me to do engineering was somebody told me the difference was maybe that I would get to actually make things, or I would get to apply science and kind of end up making products and doing things like that, which is kind of what brought me to my fellowship. I wanted to get an experience where I got to actually be in an environment where we were engineering things and making things. So I said Proton, they do hydrogen generators. Those do much more than fuel cell cars. They use them in they sell them in many different areas. We sell lots of products across the world. So there's a lot of opportunity there to use my skills and actually make an impact on the manufacturing floor. So that's sort of, I guess, I hope that answers your question about that. But what inspired me was applying what I've been learning in school to real things.
So when in college, was it in the middle of your career, in the middle of college, or at the beginning?
So it was at the very beginning.
Did you switch your major?
Yeah, I got lucky in that right before, so freshman year, I was thinking about doing chemistry or biology, and somebody snagged me. One of the advisors snagged me up and said, maybe you should think about chemical engineering. What's chemical engineering? So I just got kind of lucky. Somebody kind of saw something, I think, in me and thought they'd encourage me to try that out. He said the worst that happens is you can just switch back to chemistry, right, if you really want to. Because they're similar classes at the beginning. But I had a lot of mentors in undergrad that definitely kept me in the program, encouraged me to pursue my own interests. Again, it was a small program. I got a lot of individualized attention. I got to do research projects on things on my own. So that helped a lot.
Great, thank you.
So I think for me, the stories are different. Growing up in France, for the first 7 years of, for the first 9 years of school out of the 12 years of from elementary to middle school, everybody take the same classes. So the level of math and science, there's no option there. Everybody goes through the same very intensive of both, whether it's from the French language, studying history, to studying math and science. And only after 9 years do you really have to kind of decide, do you want to get more into science, get more into language and economy and things like that. So I think, fortunately I got lucky, that the process really helped me, as I was kind of good with math to start with. I thought it was fun. The school system itself really didn't make a big difference between boys and girls at that time. only after when I decided when I had to choose, when I was right around 15 years old, just like, do I want to get more into science, do I want to get more into, more like, languages and history or other type of education, I just realized already math was probably the easiest way out for me. And luckily at this time, my math teacher really the one who encouraged me to get into engineering. As I was getting closer to graduate from my school, she told me, really, you should consider engineering. And I was like, well, what is that? She's like, it doesn't really matter. It's a very good degree to have. You get the right skill set, and it's going to open a lot of doors. And being 17 years old at the time, I'm like, yeah, sure, why not? So I would say then when I go into the program, some of the things I really enjoyed, as I mentioned before in my introduction, is the fact that I got exposed to a lot more than just pure engineering. What is engineering? Engineering is a way to, as I said, to approach problems. Yes, you learn very specific skill, whether it's chemical engineering, mechanical engineering, that you'll be able to apply down the road, but you're also training your brain into learning a lot, into approaching situations, into building stuff, into fixing stuff. And I think that's a good skill set that you can apply way beyond. And I really thought, I still think to this day for most people it is easier to start with a technical degree and then go even to business school, go and work for a company and learn some of the business acumen than in the reverse, becoming as more of a business or more general degree and then try to get into very deeply technically. So I really see engineering and science in general a good way to get into to get a job, just first of all, but to really learn some specialty that's going to open door and open door to build a large corporation, and really maybe improve on your skill set and go deeper into the science, or take that and apply in a more general way as well. So I think from an option standpoint, it gives you a lot more option and flexibility. To speak a little bit about some of the statistics, I think for me, obviously I don't think I'd be where I am today if I hadn't started as an engineer and really got started into the plastic side of the business from my chemical engineering degree. So that's an obvious one. But I'm also proud to say that as we grow the company and that we're growing the company, we're really welcoming women in general. I think there's a lot of skill set that women, bring to a company and to some of the problem solving, to some of the management, of a team. So today in our company, for example, 43% of our employees are women. Unfortunately, only a third are from a STEM background, where for the men it's almost half, 50%. So obviously there's still a lot of work to be done to bring more women, with STEM degrees, and to encourage young women to really, don't be afraid. It's not that difficult. It really is not. It may sound a little scary, but it really is not that difficult. It's not almost, I think English or French is a lot more difficult than, math and science, but that's me. So I think, as a company, we are really, diversity is key. We have a lot of people from different backgrounds, different countries, a very good mix of, men and women, a very good mix of, we love to hire, like new graduates. We have a lot of, I think 3 of our employees were just hired right out of school, but we also bring on board with people, of ages as well, bringing different skill set and experience. So I think diversity is key.
For me, I think the interest in engineering started very early because my father is an engineer, my brother is an engineer, my uncle is an engineer. They're different. My father is an electrical engineer, my uncle is a mechanical engineer, and my brother is a civil engineer. So it was kind of a family of engineers. So for weekends for me was really opening up stuff and putting it back together because that's what my father liked to do. And I got interested in how things worked and just that curiosity of understanding the various components that go into a mixer, for example, or the car. We would take spark plugs out and clean it and put it back in on weekends. We would change the oil. It was just stuff like that I grew up with. So by the time I was in my teenage years, I was very sure I was going to be an engineer of some kind. I didn't know which one yet. And so when I got the opportunity to be a mechanical engineer, I took it and thoroughly enjoyed it.
Great, thank you. During the course of your career, you all told me at different stages that mentors were very, very important to you. Someone played a role either directly, and you can say that person, or when you thought back on it, you thought, oh, that's probably helped the path. So I'd like you to talk about where in your career path the mentor was important, number one. And then I also got from all of you that it's become just ingrained in you that you will be a mentor. And it's just sort of like, as I said, I think to one of you, paying it back. And it just becomes this ongoing thing. So talk a little bit about the important chip and who was your mentor, or a couple of people that were your mentors.
Sure. I've had a lot of really important mentors in my career. I think the first one that I reflect upon with like a lot of fondness would be my first research mentor, because he let me do research as a freshman in college, which is kind of rare. So he took a chance on me, but he told me right away, you know, I'll let you do whatever you want in the lab. You know, if you don't get anything done, that's your own fault. So he really trusted me to do kind of my own thing, and it really worked well for me at the time. I did a lot. I actually got on a publication early in my career, which was really exciting, and it just sort of fueled this interest in research in me in a very early stage in my undergrad career. But him taking a chance on me and mentoring me through the whole process of science was key to that thing. And then I had a lot of mentors in graduate school, but I think one of the more recent ones I want to talk about is Kathy Ayers at Proton OnSite did also take a chance on me, because I applied to work at her company not having a lot of electrochemical background. But I think she saw, you know, maybe just in my interview with her and talking to her, that I had a very big capacity to learn and push things, and I had drive. So, and she's been a great mentor so far. I've learned a lot through my postdoctoral fellowship, and I've been able to accomplish a lot there in a short amount of time. And I don't think that could happen without a mentor like Kathy. That said, I've also had a chance to be a mentor throughout my career. So I've mentored a lot of undergraduate students with different projects, and I continue to do that actually at Proton. I have a few projects where I get UConn students to come in, and they do research projects for a semester, and it is amazing how much work they can get done with all their classes and you know, not knowing much about the project beforehand. So it's really rewarding to see them come out at the end with this, you know, goal accomplished and learning a lot. And they all have smiles on their face, so we must be doing something there. But I find that really rewarding. So mentoring somebody else through the same process is really important, and it's fun.
I think I have a lot of mentors and people influenced through my life. Whether it was, you know, my French teacher who, you know, were the one to push me into engineering. Whether it was my parents who let me play with Barbie, but also, you know, play with Lego and build houses and build stuff. So being able to still be a girl, but at the same time not stopping from playing with cars or playing with Legos and, you know, building all the fun, you know, blocks and houses I wanted to put together. Through, you know, most recently 15 years ago, Scott DeFelice, who was over there, who gave me a chance 15 years ago when I barely spoke English and was just like an exchange student from France. After saying no many times, finally gave me a chance to actually, you know, work for him. And, you know, it's been quite a journey, you know, in the past 15 years where, you know, I learned a lot. I definitely hope, you know, I bought a lot as well. And you know, one of the fun aspects of, you know, working for a small business and being part of the growth of the company is like you bring a lot of people, you know, to work with you. You're part of, you know, the team who bring people in. And, you know, and I don't know how I've really mentored everybody. I just know that, you know, I've been part and continue to be the part of, as we recruit people and bring them in, I can teach them, you know, some my successes and my mistakes. You know, I cannot give them a favor for what it takes and what I've done right and done wrong. And I also think, you know, when you think mentor, it's a much better approach to management than being a dictator. So I think, when you think of mentorship, you can look at it in a much broader way in how you would manage your team, how you would work with your colleagues, because I think we all have a lot to learn over, all over a career in your life, as well as we have to teach, So I think I look at mentorship as a very broad role, how you communicate with people, how you kind of share some of your experiences, and how you bring people on board as well. It's been really nice to be able to bring some of those young engineering to our company and kind of give them a chance at a job, a chance to learn how to do things, but a chance for them to teach us, some of the new, what they just learned at school that maybe none of us have been exposed to. So I think this is part of mentoring, is being able to bring some of this younger generation as well, and kind of give them a chance, because, we really love to hire people with the right experience, can jump in right away, but, we all have to start somewhere, so we have to give a chance to some of those young graduates as well.
Mentors and influences, I think started very early. In school, it was the teachers, it's the math and science teachers who took special interest in making sure that we were getting the concepts, we were understanding the basic foundation of these subjects so that we could shape to become professionals in the future. My father, my parents were a big part. They helped us as well at home. Coming out of high school and getting into the professional colleges, getting into engineering, there were professors who were very good, who were very interested in making sure we learned these subjects and were able to apply it. When I came to graduate school in the U.S., my advisor was an incredible person. He was a great mentor. He was part of everything I did, whether it was a housing problem I had or it was a subject matter issue. He was always there, and that helped a lot, especially there are some very challenging times when you're going through a graduate dissertation. And you need all the support you need, not only from the professors and advisors, but from your peers as well. Coming out into the workforce was another challenge. I had to find mentors to be able to navigate the corporate system, because it was something that was new to me. My parents didn't come from that kind of background. They did not have the corporation kind of experience. So it was something that I had to seek out, and people were very willing to help when asked. In the first job I had, it was a woman-owned business. She was an extremely dynamic lady, was a great role model. When I went to Rolls-Royce, the mentors that I seeked out were extremely helpful and helped shape the opportunities that helped me grow in the organization. Same thing is happening at Sikorsky. I have several mentors at Sikorsky who help me when there's a difficult situation or just in some career advice in general. And that has really helped not only establish myself in a new company, but be able to progress as well.
So if we think about the mentors of being through your career path, and now you're gainfully employed, you're working in an organization, I'd like you to address your individual companies, if you're comfortable with talking about it, of how they help now that you might have a mentor, and some of it could be a mentorship inside the company, but what do your individual companies do to cultivate that support for women, and how can you leverage that with it continuing and being sustainable to help that company even cultivate that culture in a more positive way, so you can bring some more people in that you will eventually mentor, but you can grow that organization and do some outreach to women. What does your company do to support that for you?
So I think that there's two different aspects here. There's helping you there's two different aspects to mentorship. So there's helping you succeed, there's being there for you when you have a problem. There's trying to identify your strengths and weaknesses. So there's kind of that whole review process, and somebody spending the time to think about that and have that perspective and really care about you as a person, not care about how much work they can get out of you, right? So I feel that Proton's really good about communicating that that's what they want. They want you to grow as a person, as a professional, rather than I don't feel anyway that you're just a cog or something. I think that communicating even that's a goal for them or goal for anybody in a company, I think is really important. It makes you feel very valued and safe and secure. What Proton does specifically, I've already mentioned. Kathy's a really great mentor. She's a woman role model, which is always helpful. So she helps a lot with just the kind of the female aspect of that. But in addition to that, we've hired a lot of engineers. Many of them are also women. We don't really seem to have any, I've been part of the hiring process, and I can say it's very professional. That always helps. There's no conversations about that. I think that it's just a communication thing as far as maybe, caring about a person enough to say, these are areas I want you to work on, these are things I'm not, or being there for somebody, and also being an advocate for them. So Kathy's a great advocate for me. She put me here. She was actually suggested that I come here, gave me these opportunities. And Proton's really, I think those are values that they hold and they communicate to their employees, so we all know these are all values that we hold.
I think for us, as I mentioned before, I think overall, mentorship is a nice way to work with your team, work as a team, and manage a team. But I think also, I mentioned some of the numbers before. So without discriminating, we are trying to bring and hire women. It's always a sensitive topic where why do you choose that individual for that job? But we are at some level making a conscious effort as well as we bring people to hire young engineers that are women. I was actually very pleased about a few months ago when we get a group from the Yukon Engineering Ambassador Program come to our facility, and we give them a tour and discuss, this little Q&A on our products and our technology. That of the 6 engineers that came, 5 of them were women. So I think there's definitely that felt good on a personal level. That felt very good. So we've been making conscious effort to make the company. We're small business, fast growing, but we're also very we try to be very flexible to accommodate any type of individual and any type of personal needs. So I think this is definitely a very good environment for women, but we're also not trying to make it a difference. Because I think at the end of the day, women and men are as capable to do the job. They will just have, as individuals, not as genders, different skill sets. And, you don't want to have to choose one or the other because this is a man or a woman to do the job. So I think we've done very well in looking at our needs and finding the right person for it. And luckily, almost half of the time so far, we've been able, we have hired a woman for this. I'm also very happy to say that a lot of those women are either from engineering background or in management position as well. So I think as a company, we don't specifically look for women. However, we see great value in having a very diversified environment. We will continue to do so. And I've been very pleased when looking at some of the Yukon young engineers to see there's quite a few women that are interested in working in our field and who actually are contacting us on a regular basis to look for opportunity once they graduate. So I think that's very promising as well.
Sikorsky's products are used in 40 countries. It's a global company. We have about 16,000 employees worldwide. The program I work on is a Turkey. It's a helicopter for the Turkish customer. And diversity is very important for a company that is global and growing globally. It is in everything we do. The inclusive environment, the collaborative environment, entertaining ideas from different backgrounds. It is a good discussion we have since we realized the benefits of being global. And diversity is a large part of being global. The company takes a lot of initiatives. I personally have been part of the Society of Women Engineers. We go every year to the conventions. We recruit at those conventions. One of the persons we recruited last year is now working in my group, and she is great. So it's keeping active in these associations and starting early. I think going into schools and trying to get women interested in science, technology fields is important, because personally I feel like that's what made the biggest impact for me, is starting early, getting that interest early. We also take part in other organizations like the Women in Aviation International. We also go to recruiting events at other engineering groups, and we very actively recruit with the main goal of making sure that the diverse ideas and candidates are considered.
I heard from Severine before that you thought your career, your education in engineering has given you a very good foundation, that you can learn other aspects of the business about that. So I'd like you to speak a little bit about that, and then to instill some less fear if somebody is teetering about going into it. How will that help them out in the future, even if they don't stay in engineering? How could they transfer that skill set to something that's usable into another career path, to at least give it a try? Because I think that's some of the hurdle.
Sure. I think you hear a lot of people say that they don't really, you learn a lot of these things in undergrad, but they don't use many of them today, right? So a lot of people will say that. A lot of what you learn in undergrad is how to solve problems, how to approach problems, not necessarily this is exactly what I'm going to do every time I do it, right? So you kind of learn the mechanism. So that should maybe ease some of those fears. I will say that I went into this postdoctoral fellowship not knowing much about the field, so it was very scary. And I did lean a little bit on, okay, well, I've got all this education, hopefully I can figure it out. And I did. I really did. I think that taking that leap of faith was really really important actually for my career, because now I have confidence that I can solve more problems. If I'm going to encourage a young person debating whether or not they want to go into this, I would say that one reason why I went into it is I didn't want to be bored of my job. I felt like engineering gives you the opportunity to kind of jump. If you really don't like your job, you can jump. You can get interested in something else and do well at that and do that instead. And so it really opens up a lot of doors. It'll give you the opportunity to have a fulfilling career because you are in control of it. You know how to be in control of it. So I think that's what I would say. I would also say that a lot of I've done some work in outreach, and there's some statistics, and I'll have to give them to you sometime later, but it says a lot of young women especially want careers that help people. And I think there's a miscommunication out there that engineers need to know math, but that's not really what it is. And engineers really help people. They make products that are in everyday lives. They save the consumer money. They make their companies money. They help people. It might not be a very direct thing, but I think that communication maybe needs to be started in that conversation. How do engineers help people? Well, they do a lot of really, really great things. So I think communicating that to our youth might also help encourage them to enter these kind of careers.
Yeah, I think first of all, when you think about women in general, and how kind of alleviate some of that fear of engineering and math, and when you look at what women have done over the century, they should not be really afraid of engineering. This is really not that big of a deal. That women have raised family, women have taken care of a lot of people. So I think going through 4 or 5 years of engineering program is probably. It's really not that difficult at the end of the day for women either. So I think that's the first thing I like to mention. Then I think engineering, what I like about that field is kind of give you options. So, in my example, that was a way to get into the business actually, an entry into, the world of polymer that ultimately turned into a business opportunity. And it gave me the skill of, as I mentioned before, problem solving, engineering solution, engineering product. Engineering is a big word that means a lot of different things. But it's also give you the opportunity to become a specialist in the field as well and advance into PhDs and other type of, science. So by starting with a degree like engineering, you actually have the option to go very deep into the science and use that at a professional level, or actually take what you've learned and the skill set of learning of engineering solution and apply it outside of maybe your area of expertise. So I think, what it is for me, engineering actually gives you a lot of flexibility. And I think they give you a lot of flexibility, and flexibility is important for individual. You know, you never know where you're going to be 5, 10, 20, 30 years from now. So I actually think at some level, engineering gives you that. You know, you can pretty much do whatever you want once you graduate. So I think that's been kind of the way I look at it.
Well, I agree with, after you do an engineering degree, your way of thinking has been shaped to be very analytical and logical, which can be applied to other fields, whether you want to get into business or you want to get into any other area. That's always an asset to have that you can pull on to grow from. A lot of people do very well from engineering in program management. They get into the business side and do very well as well. The other way is not possible, really. It's like, getting a business person to do an engineering job is really not possible, but the other way around is. So it is to have the technical foundation. I think, it's a great thing to know what your product is, to be, even if you're in business tomorrow, you decide to go into a business area in your company, it's good to have that technical knowledge, because now you know your product really well and you can apply those business techniques to grow and improve your products even better. The engineering field itself lends itself very well, I think, to move around. For example, when I started, I got an engineering degree. I got into the core engineering function first, and then decided I wanted to be a generalist. I did not want to be a core specialist, and that was a choice that I did make, because I just wanted to become more broader. I wanted to see a bigger area of the business. And so I moved into project management that gave me that opportunity. So I think even within engineering, I'm still in engineering, I think even within engineering there are options that you can choose to, depending on what your interests are.
Great answers. I'd like to throw it out to our audience for some Q&A from our great panelists here. I said that was probably my mother and my aunt in that reserved section up front that they would be here to critique me as leading the panel, but that's a great question, whether it's family or outside mentors. Has that ever happened?
So she asked if it's possible to be over-mentored. I think everybody has a mentoring style, I will say, and mine does not lend well to micromanaging. So my graduate advisor, I love her, but I was her first student, and she was very into what I was doing a lot. A lot. This happens a lot with first students, so she kind of was always around the lab and just making me nervous. So I think it's maybe not so much over-mentoring, because she really cared and I appreciated that, but I think it's finding the right style to work with your mentees. Like, how much pushing do they really need, and how much scaffolding? Because you want to let them fly on their own a little bit, right? You want to let them know you trust them. So that's kind of what I have to say about that.
I think over-mentoring would probably be called micromanaging, so it's probably a way to over-mentor. I think to be over-mentored is probably a lot harder, because when you're being mentored, you also got to take it and make it your own. So this is your own responsibility to take it and take the pieces that you feel comfortable and apply them. So I think being over-mentored is probably a choice of that you make. And over-mentoring, maybe if you a little too passionate at times, probably does happen. But I think there's probably very little over-mentoring if it's truly mentoring. I think that's the way I look at it.
Right, I kind of agree. I don't think there's any over-mentoring. I think, to me, it's taking all that information, and then the decision is really yours in the end, whatever you want to do. But getting that advice from various sources is actually good. So that you can take all that information and make a decision for yourself. if it is that kind of a time, if you're trying to see whether you want to make a different career choice or you want a different position or, you got to follow your passion in the end and take the advice, with keeping an eye on that, right? Making sure that you're doing what you really want to do in the end.
Any other questions for the panelists?
So I heard different age levels where you got interested in engineering. I guess from the three of you, what would you recommend? What is that age group that you would go encourage young girls to consider careers in engineering, careers in manufacturing? What level do you really need to go to attract girls into the field?
What age group? Where would you start with the attraction?
I would start as young as I could, I suppose. I mean, I guess, because looking back, I think I could see I was maybe I was playing with Legos and building little houses since I was really little, I suppose, Yeah. And so I suppose, because with my nieces or young kids, I try not to, I try not to differentiate between toys, I guess, I might give young boys other toys that girls should have, I think and I don't know, I'm not a parent, so I can't tell how hard or difficult that is, but I can say that my parents my dad's he works on roads, so he gave me, sandbox toys from when I was little, because that's what he did, so I think it was a matter of, I never even grew up with the concept of that not being normal, I suppose, and I have a benefit because I'm isolated from the rest of the world growing up in North Dakota, but, I never really got an influence like that. So I would just start as young as you could. I think that encouraging kids to play and be interested in all kinds of things is always fun.
Yeah, I guess we have the Lego thing in common. I think that you start very early, and I think you start with not everybody is still going to go into engineering. You want to push, but it's got to be the right fit as well. So I think you want to nurture that and encourage it early on if you see that type of, attraction or abilities. But it starts early, but it's also never too late. I think, you have a chance, in college to do that. I think that, again, the sooner you start, obviously, the better. But the sooner you start without making almost either difference, like, just making sure that it's all a possibility, not just engineering, but they are all possibility, not pushing too much one way either, I think is important. But I think, the sooner you can recognize that someone has this type of ability, and maybe you want to nurture it at that point, you want to maybe, push it a little, or I think that's very important. I think definitely, in the early teenage years, I think that's critical, and that's why you really start shaping your personality. So at that point, I think you should probably, make sure that, through the school system, there's very good, push for, math and science. That we ultimately, even though engineering is not just that, this is kind of some of the basis to get into engineering as well.
I will say my sister became an art teacher, so, some kids just respond to things differently, same exact environment. My sister wanted to do art, so, I don't know. Yeah.
There's a certain aptitude for sure, but it's nurturing that curiosity and that passion that a child might already have before the stereotypes take over and kind of, take that person out of that interest, and it doesn't get nurtured. I think it's kind of, so it should start very early in school, where the math and science teachers are taking this interest to make sure that the students are really nurturing that passion is where it should really start. And then towards the areas where it's really critical to where the choices are being made, like colleges and all, is where it should really get shaped to where that interest is really channeled into a course, or to achieve something. Most times, I think the girls especially, they have the interest, but they don't have the other influences like role models, so they don't have mentors within their immediate family or friend circles, and that's kind of where it can fall apart. And not everybody is going to be an engineer, but there is a much larger number than what we see in our workforce today that should be engineers, and that's the group that we're really targeting.
Yeah, I think in general, like, having if the teacher has the kind of the ability or the training to recognize, oh, this person is very analytical, this person is, this kid, and really kind of guide them through it, that, recognize that because it would be a better fit down the road. And to, the point you made earlier, it's like, it's a lot easier to learn the technical, to learn the technical side of things early on and then apply it to the field that vice versa. So I think, making sure that our teachers, know how to, like, recognize some of these, like, early abilities or, like, preferences, I think would be very helpful, because then they can help guide. Because to the point, not everybody in your family, my parents were not engineers, so not everybody close to you are, in your family could be a mentor. So at that point, that becomes, your teacher is going to be, the one closer to you to see some of those abilities. So I think that is key, to give the teacher the right, the right training to recognize, okay, why we make a good engineer, why we make a good scientist, why we make a good, accountant or things like that. So I think that would be great.
So I guess just speaking to the group at an earlier age and speaking in just a generic fashion versus a female versus a male fashion would help, and the earlier the better, and good for those who have, as you have mechanical uncles, a mechanical engineer as an uncle and an electrical engineer as a father. Take your girls outside with you. So, you have no choice. Is there anything?
Yes, thank you for the presentation. I wanted to pose a hypothetical situation. Assume for a moment, can you hear me okay? Assume for a moment that you were approached to put together a Nobel group that would look at technology in energy and food and clean water. Could you tell us what technology you would like to lead towards a Nobel Prize?
Well, I mean, I wouldn't be working at Proton OnSite if I didn't think it was promising, would I? I think I'm just going to speak to my own technology. I think that electrolysis has the potential to impact, and actually the stuff that our company does has the potential to impact all those things. I mean, I will say that I think clean energy is important. Energy storage is important, and hydrogen is a platform there that's actually very flexible. So not only can it be used in a fuel cell, but it can be used in many different ways. It's flexible, so you can store this wind and solar energy, right? That's on the grid. So I guess I will root for my own company there. Or also if we have projects that are, I'm actually writing proposals for water cleaning technology through our stacks, as well as ammonia production, things like that. Clean ammonia production that doesn't use the Harbour-Bosch process. So I'm going to push my own company.
I guess I'm going to do the exact same thing, and I'm going to tell you why. I think actually the technology platform is already improving, patient outcomes. So one of the products, we get cleared by the FDA is a cranial implant that is actually 3D printed right from the CAT scan. So it's actually a perfect fit. So we are reducing time in surgery, which means less infection. It means, less time in anesthesia and risk for any complications. So right there, we're already, making the patient, outcome much better. So I think right there, and we're also making, we are making skull replacement that you couldn't make before. We actually did a case where the entire head from here to here was replaced. There was no other technology, and to do that before. If you had seen the CAT scan on that poor woman before, you would feel like, this is really, this is amazing. So I think, this is one area definitely where I think we're advancing the science. We have ideas of long bone, replacement, small implant, a lot of the technology at the platform to really improve patient life, human life in general. And I think the same applies to the other area, not only medical, but in aerospace. We're making things lighter. We are replacing aluminum. So by making things lighter, we're using less fuel. Well, that's kind of the beginning of something kind of clean. less fuel, it's definitely cleaner. And the same thing when you look at our technology and our product at the basis for innovation and looking at a lot more like clean energy as well. We've got a lot of ideas with this material and this 3D printing technology that ultimately, as we advance the science, I'm not saying we deserve a Nobel Prize today, but I think, the way we are advancing the technology and we're actually improving, patients' life and making the environment, cleaner, I think this is definitely, very good contender in maybe 5-10 years from now.
I would say energy as well. Since I worked in the jet engine industry before I came to Sikorsky, and we were constantly looking at saving fuel. That was our biggest. We tried to improve our engines to be able to be more fuel efficient. We had great programs that we went after. We do the same thing at Sikorsky as well. So I think energy is a big issue for where we are in our industry.
We've got great ideas. We just need more women to put it all together and do it. But I want to thank all of you for participating. Thank our 3 great panelists. Thank CTC for keep doing you'll see it up there, the 10th anniversary for attracting women in engineering and keeping this very important program going. And thank you so much. And go recruit a woman.